Electric West is the largest electrical industry event on the West Coast, often referred to as the Super Bowl of the electrical industry. Attending Electric West presents a valuable opportunity to expand one's knowledge, network with industry professionals, and stay abreast of the latest advancements in electrical technology. The event typically features a wide array of exhibitors showcasing products and services related to electrical construction, maintenance, and safety. Seminars and workshops led by experts in the field cover various topics, including the National Electrical Code, grounding and bonding, motor controls, and energy efficiency. For those new to the industry, Electric West offers a comprehensive overview of the electrical landscape, providing insights into different career paths and emerging trends. Experienced professionals can benefit from advanced training sessions and networking opportunities, allowing them to enhance their skills and stay competitive. The National Electrical Code, or NEC, is a comprehensive set of standards governing the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and address emerging safety concerns. Understanding the NEC is crucial for anyone working in the electrical industry, as compliance with its requirements is essential for ensuring the safety of people and property. Grounding and bonding are critical components of electrical safety systems. Grounding provides a path for fault current to flow back to the source, allowing overcurrent protection devices, such as circuit breakers and fuses, to trip and energize the circuit. Bonding ensures that all metal parts of an electrical system are at the same electrical potential, reducing the risk of electric shock. Proper grounding and bonding techniques are essential for preventing electrical hazards and ensuring the reliable operation of electrical equipment. Mike Holt is a renowned electrical educator and author, widely recognized for his expertise in the National Electrical Code and electrical safety. His seminars and publications are highly regarded in the industry, providing practical guidance and clear explanations of complex electrical concepts. Many find Mike Holt's teaching style engaging and informative, making him a popular choice for continuing education among electricians and electrical contractors. His focus on real-world applications and practical examples helps students to grasp the underlying principles of electrical theory and apply them effectively in their daily work. The Electric West presents an excellent opportunity to attend seminars led by Mike Holt and learn from his vast experience. These seminars typically cover a range of topics related to the National Electrical Code, grounding and bonding, and electrical safety, providing valuable insights and practical skills for electrical professionals. Attending Electric West is highly recommended for anyone seeking to advance their career in the electrical industry, whether they are just starting out or have years of experience. The event offers a unique opportunity to learn from industry experts, network with peers, and stay up to date on the latest trends and technologies. Investing time in studying the electrical industry and the National Electrical Code is essential for professional growth and success. A solid understanding of electrical principles, safety practices, and code requirements is crucial for providing safe and reliable electrical services. Continuous learning and professional development are essential for staying competitive in the ever-evolving electrical industry. There are numerous resources available to help individuals expand their knowledge and skills, including online courses, textbooks, seminars, and industry publications. Taking advantage of these resources can help electrical professionals to stay abreast of the latest advancements and maintain their expertise. Grounding and bonding are essential for safety. One aspect is understanding the purpose of the equipment grounding conductor, often referred to as the EGC. The EGC provides a low impedance path for fault current to return to the source, facilitating the quick operation of overcurrent protection devices. The size of the EGC is determined by the size of the overcurrent protection device protecting the circuit, as specified in NEC Table 250.122. Another critical element is the grounding electrode system. This system typically includes a grounding electrode conductor, which connects the equipment grounding system to a grounding electrode, such as a ground rod, ground plate, or metal water pipe. The purpose of the grounding electrode system is to provide a connection to the earth, stabilizing voltage and providing a path for dissipation of transient voltage surges. Bonding involves connecting all non-current carrying metal parts of an electrical system together to create an electrically conductive path. This includes metal conduits, enclosures, and equipment frames. The purpose of bonding is to minimize voltage differences between these metal parts, reducing the risk of electric shock. The NEC specifies the requirements for bonding different types of equipment and systems, including service equipment, separately derived systems, and swimming pools. Article 250 of the National Electrical Code provides detailed requirements for grounding and bonding. It covers topics such as grounding electrode systems, equipment grounding conductors, bonding jumpers, and methods for grounding different types of equipment. Understanding Article 250 is crucial for ensuring the safe and effective grounding and bonding of electrical systems. Overcurrent protection is a critical safety feature in electrical systems. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a predetermined level. This protects equipment and wiring from damage due to overloads and short circuits. Circuit breakers are resettable devices that can be tripped manually or automatically in response to an overcurrent. Fuses are one-time devices that must be replaced after they have blown. The selection of the appropriate overcurrent protection device is crucial for ensuring the safety and reliability of an electrical system. The NEC specifies the requirements for overcurrent protection in Article 240. It covers topics such as the selection of overcurrent protection devices, the coordination of overcurrent protection, and the protection of specific types of equipment. Understanding Article 240 is essential for designing and installing safe and effective electrical systems. The ampacity of a conductor is the maximum amount of current that it can carry continuously without exceeding its temperature rating. The ampacity of a conductor is determined by its size, insulation type, and installation conditions. The NEC provides tables that list the ampacity of different types of conductors under various conditions. It is important to select conductors with an ampacity that is sufficient to carry the expected load current, taking into account any applicable directing factors. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Voltage drop can be calculated using Ohm's law, taking into account the length of the conductor, its resistance, and the current flowing through it. Wiring methods refer to the various ways in which electrical conductors can be installed. Common wiring methods include rigid metal conduit, electrical metallic tubing, flexible metal conduit, and non-metallic sheathed cable. The selection of the appropriate wiring method depends on the application, the environment, and the NEC requirements. Each wiring method has its own advantages and disadvantages in terms of cost, ease of installation, and protection against physical damage. The NEC specifies the requirements for wiring methods in Chapter 3. It covers topics such as the installation of raceways, cables, and boxes, as well as the support and protection of wiring. Understanding Chapter 3 is essential for installing electrical wiring in accordance with the NEC. Electrical panels, also known as load centers or distribution panels, are enclosures that house circuit breakers or fuses and provide a means of distributing electrical power to various branch circuits. Electrical panels typically contain a main breaker, which serves as the main disconnect for the entire panel. The size of the main breaker is determined by the service entrance conductors. Branch circuit breakers protect individual circuits that supply power to lighting, receptacles, and equipment. The NEC specifies the requirements for electrical panels in Article 408. It covers topics such as the installation of electrical panels, the grounding and bonding of electrical panels, and the protection of electrical panels against overcurrent. Electrical safety is paramount when working with electricity. It is important to follow all safety precautions and use appropriate personal protective equipment such as safety glasses, gloves, and insulated tools. Always de-energize circuits before working on them, and verify that they are de-energized using a voltage tester. Never work on live circuits unless it is absolutely necessary, and then only with proper training and precautions. Arc flash is a dangerous phenomenon that can occur when electrical equipment is energized. An arc flash is a release of energy in the form of heat, light, and pressure that can cause severe burns, injuries, and even death. Arc flash hazards can be mitigated by using appropriate personal protective equipment, such as arc-rated clothing and face shields. Electrical equipment should be regularly inspected and maintained to prevent arc flash incidents. Lockout/tagout procedures are used to ensure that electrical equipment is energized and cannot be accidentally energized while work is being performed on it. Lockout involves placing a lock on the disconnecting means to prevent it from being operated. Tagout involves placing a tag on the disconnecting means to warn others not to operate it. Lockout/tagout procedures should be followed whenever electrical equipment is being serviced or maintained. Electrical testing is used to verify the safety and functionality of electrical systems. Common electrical tests include voltage testing, continuity testing, and insulation resistance testing. Voltage testing is used to verify that circuits are energized before work is performed on them. Continuity testing is used to verify that there are no breaks in the circuit. Insulation resistance testing is used to verify the integrity of the insulation on electrical conductors. Electrical troubleshooting is the process of identifying and resolving electrical problems. Electrical troubleshooting typically involves using a multimeter or other test equipment to measure voltage, current, and resistance. Electrical troubleshooting requires a thorough understanding of electrical principles and the ability to interpret electrical schematics. Continuing education is essential for electrical professionals. The electrical industry is constantly evolving, with new technologies and code requirements being introduced on a regular basis. Continuing education courses and seminars can help electrical professionals to stay up to date on the latest developments and maintain their expertise. The National Electrical Code is updated every 3 years, so it is important for electrical professionals to stay informed of the latest changes. The NEC is available for purchase from the National Fire Protection Association. Electrical apprenticeship programs provide a structured pathway for individuals to enter the electrical trade. Apprenticeship programs typically involve a combination of classroom instruction and on-the-job training. Apprentices work under the supervision of experienced electricians and learn the skills necessary to become licensed electricians. Electrical licensing requirements vary from state to state. In most states, electricians are required to pass an exam to obtain a license. The exam typically covers electrical theory, the National Electrical Code, and local electrical codes. Electrical contractors are required to be licensed in most states. Electrical contractors are responsible for the design, installation, and maintenance of electrical systems. Electric West will likely have exhibits for ground fault circuit interrupters, or GFCIs, which are designed to protect people from electric shock. GFCIs monitor the current flowing in a circuit and trip the circuit if they detect a difference of 5 mA or more between the outgoing and return current. GFCIs are required in bathrooms, kitchens, and other wet locations. Arc fault circuit interrupters, or AFCIs, are designed to protect against fires caused by arc faults. AFCIs monitor the current flowing in a circuit and trip the circuit if they detect an arc fault. AFCIs are required in bedrooms and other living areas. Surge protective devices, or SPDs, are designed to protect electrical equipment from voltage surges. SPD divert excess voltage to ground, preventing it from damaging sensitive electronic equipment. SPD are recommended for homes and businesses that are located in areas that are prone to lightning strikes. Electric motors are used in a wide variety of applications, including pumps, fans, and compressors. Electric motors convert electrical energy into mechanical energy. The efficiency of an electric motor is the ratio of the mechanical power output to the electrical power input. Energy efficient electric motors can save significant amounts of energy and money over their lifespan. Lighting is a significant consumer of electrical energy. Energy-efficient lighting technologies such as LED lighting can save significant amounts of energy and money. LED lighting is more efficient, longer-lasting, and more durable than traditional incandescent lighting. Renewable energy sources, such as solar and wind power, are becoming increasingly popular. Renewable energy sources can help to reduce our reliance on fossil fuels and reduce our carbon footprint. Solar panels convert sunlight into electricity. Wind turbines convert wind energy into electricity. Energy storage systems such as batteries can be used to store energy generated from renewable energy sources. Smart grid technologies are being developed to improve the efficiency and reliability of the electrical grid. Smart grid technologies include smart meters, which provide real-time information about energy consumption. Smart grid technologies can help to reduce energy consumption and improve the efficiency of the electrical grid. Electric vehicles are becoming increasingly popular. Electric vehicles are powered by electricity and do not produce tailpipe emissions. Electric vehicles can help to reduce air pollution and our reliance on fossil fuels. Charging stations are needed to support the growth of electric vehicles. The NEC contains specific requirements for wiring methods. These requirements are found in Chapter 3 of the Code. Some common wiring methods include rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or IMT, flexible metal conduit, or FMC, and non-metallic sheet cable, often referred to as ROMICs. Each wiring method has its own set of rules regarding installation, support, and permitted uses. For example, RMC is a heavy-duty conduit that provides excellent protection for conductors in harsh environments. EMT is a lighter weight conduit that is commonly used in commercial and residential buildings. ROMICs is a non-metallic cable that is widely used in residential wiring. Selecting the appropriate wiring method depends on the specific application and the environmental conditions. Another important area covered by the NEC is grounding and bonding. Grounding refers to connecting the electrical system to the earth, while bonding refers to connecting all non-current carrying metal parts of the electrical system together. The purpose of grounding and bonding is to provide a safe path for fault current to return to the source, which helps to prevent electric shock and fire hazards. Article 250 of the NEC provides detailed requirements for grounding and bonding. The NEC also contains requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When an overcurrent occurs, the overcurrent protection device will trip, interrupting the flow of current and preventing damage to the wiring and equipment. Article 240 of the NEC provides requirements for overcurrent protection. The NEC also addresses the installation of electrical equipment. This includes requirements for the location, mounting, and wiring of equipment such as receptacles, switches, lighting fixtures, and appliances. The NEC aims to ensure that electrical equipment is installed in a safe and accessible manner. Chapter 4 of the NEC covers the installation of electrical equipment. The NEC is a complex and comprehensive document, and it is essential for electrical professionals to have a thorough understanding of its requirements. The NEC is updated every 3 years, so it is important to stay current with the latest changes. Attending seminars and training courses is a great way to learn about the NEC and stay up to date on the latest changes. The NEC is organized into chapters, articles, and sections. Each chapter covers a broad topic, such as wiring methods or equipment. Articles provide more specific requirements for a particular subject within a chapter. Sections provide even more detailed guidance on specific aspects of a topic. When using the NEC, it is important to start by identifying the chapter that covers the topic you are interested in. Then, within that chapter, find the article that provides more specific requirements. Finally, read the sections within the article to get detailed guidance on the specific aspect of the topic you are working on. The NEC contains many tables and examples that can be helpful in understanding the requirements. Tables provide information such as conductor ampacities, conduit fill requirements, and grounding conductor sizes. Examples illustrate how the NEC requirements apply in specific situations. When using the NEC, be sure to refer to the tables and examples to help you understand the requirements. The NEC is enforced by local electrical inspectors. Electrical inspectors review electrical plans and inspect electrical installations to ensure that they comply with the NEC. If an electrical installation does not comply with the NEC, the electrical inspector will issue a correction notice. The correction notice must be corrected before the electrical installation can be approved. Working with an electrical inspector can be a valuable way to ensure that your electrical installations are safe and compliant. Mike Holt is a well-known electrical educator who has helped many people learn about the NEC. He offers a variety of training courses and resources that can help you understand the NEC. If you are looking for a way to learn more about the NEC, I would recommend checking out Mike Holt's website. The NEC is a living document that is constantly being updated to reflect changes in technology and safety practices. It is important to stay current with the latest edition of the NEC to ensure that your electrical installations are safe and compliant. Electric West is an excellent opportunity to learn about the NEC and other important electrical topics. The event features seminars and workshops led by industry experts, as well as exhibits from leading manufacturers. If you are an electrical professional, I would highly recommend attending Electric West. There are also other important topics that one would learn at Electric West. Firstly, proper use of personal protective equipment or PPE. Secondly, understanding arc flash hazards and mitigation techniques. Thirdly, safe work practices for electrical work. Fourthly, updates on new electrical technologies and equipment. Fifthly, best practices for energy efficiency and sustainability. Sixthly, networking opportunities with other electrical professionals. Seventhly, learning about new code requirements and interpretations. Eighthly, troubleshooting and problem-solving techniques for electrical systems. Ninthly, design and installation considerations for various electrical systems. Tenthly, business management and marketing strategies for electrical contractors. It is also important to learn about how to use electrical test equipment properly, such as multimeters, clamp-on ammeters, and insulation testers. Also important is understanding the proper use of hand tools and power tools for electrical work. And lastly, knowing how to interpret electrical drawings and schematics.